Hey guys, hello guys, welcome to this wonderful platform that makes it possible for you to learn at home from wherever you are isolating yourself during these critical corona times. So standing in front of you is Chava the scientist, your physics and chemistry tutor. So today I'm back with some more physics. So we are continuing from where we left off yesterday. We were doing projectile motion. So I decided to say no, today let's do questions on projectile motion, because it's very important to do questions, because you will never know that you don't know or know if you don't do question papers. So guys, just to test ourselves, I came with a question that I extracted from the Department of Basic Education 2018 June exam. So here they are saying that point B is located halfway of the building. That means if you say, sorry, let me pick a right pen there. So if you move from A to B and then you say this is Y, that means if you move from A to the ground, how much will that be? Is 2y. That should be 2y, because point B is located half. If AP is y, that means B to the ground is also y, and then you sum them together, they give you 2y. So it's very important, as you read the question, you also analyze what the question is trying to say and write it down as you read the question. Now we go to question 3.1. 3.1, it says define the term free fall. Remember we said that the free fall is when an object falls under the influence of gravitational force only. So guys, here they are saying when you talk of a free fall, you take this particular object, the only force acting on that particular object, the only force is gravitational force. For instance, here if you check our question, they said we must ignore a resistance. Already you have an idea to say the object that we'll be dealing with here is experiencing a free fall, because they told us no, ignore a resistance. So the only force acting on that particular object, you assume at their level, if they say ignore a resistance, you assume this particular object is experiencing a free fall. Now we can jump into question 3.2. Question 3.2 is saying a ball of mass 0.4 kg is dropped from point A. So we have a ball m is equal to 0.4 kg is dropped from point A. It passes point B after 1 second. So this ball goes down here. After 1 second, it passes point B. That means T at point B is equal to 1 second. So it takes 1 second for the ball to reach point B. Right. Now they say calculate the height of point A above the ground. So we want height of point A above the ground, right? Remember we said the height of point A above the ground, if this is y, the height should be 2y, right? So if we know the height here, we can use it to find the total height, right? Because here on this particular question, we are not given much information about point A relative to the ground, we can try to use the information given about A and B to find the distance between A and B, and then if you multiply that by 2, we get the total. Now let's check our question here. We also need to write what we have, what we are given. So we wrote our mass, we wrote our time. Now one other thing that we are given from this statement, the term dropped, this particular term, it's saying dropped. By saying it's dropped, that implies VI is equal to 0. So VI is equal to 0 because it's dropped. So that means it starts from rest. So VI is equal to 0 meters per second. The initial velocity is 0 meters per second. Right. So now we need to go to our formula sheet, pick the right formulas for us to use here. We go to the formula sheet section on the projectile formulas. So right now I have them in my head, so I'll just write them down for us here. So we have the first formula, it says VF is equal to VI plus AT, right? The other one, it says VF squared is equal to VI squared plus 2A delta Y. The other formula is saying that delta y is equal to vit plus 1 over 2 a delta t squared. The other formula, it says delta y is equal to vi plus vf all over 2 multiplied by delta t. So these formulas are very important. Familiarize yourself with these formulas, know how to apply them in action. So right now we have our formulas, so we need to select the best formula that we can use for this particular question, because we said now if we find the distance between A and B, we can use that to find the total distance from A to the ground, because we don't have much information on A relative to the ground. So now we try to pick the best formula here. The first one is saying Vf is equal to Vi plus At. Now this one is talks of the final velocity. Now we only know the initial, we don't know much about the final velocity. So we can try to say no, let's discard this particular formula. Go to the next one, it says Vf. This one also talk of final velocity. So we say no, let's discard that one, and then we go again. This one says delta y is equal to Vit plus 1 over 2 At squared. So we have information on delta y between A and B, and we have initial velocity and time. Also, we know that this object we said is experiencing a free fall. That means the acceleration it is experiencing is the gravitational acceleration. So A is equal to 9.8 meters per second squared. Now, one important thing when you solve a projectile question is to assign direction. So this ball is falling in the downwards direction. So we decide to assign direction here. Now, normally I choose up to be positive, because now I choose from the Cartesian plane to say if you go up is positive, and then down of the Cartesian plane becomes negative. But you can choose up as negative, down as positive. It doesn't matter. You'll end up with the same answer. So for me, if I choose up to be positive, that means this acceleration needs to be negative, because gravitational acceleration is downwards, right? We said we can pick this formula because we have much or sufficient information. So we can go and try to calculate. Now we have delta y is equal to Vit plus 1 over 2 a delta t squared, right? So this particular ball travels a distance of y. So we can say no, finally it goes y. So let's say delta y in your level, normally it doesn't matter for you if you say final minus initial, because we choose to disregard the 0, because this one is starting from 0 going to a distance of y. So we can say no, instead of writing final, which is y minus 0, you can just write y is equal to Vit plus 1 over 2 a delta t squared, right? It's the same with time, because but let's get to the solving now. We say you want the distance, right? You want y, so y is equal to, we know Vi, we said Vi is 0, so we have got 0 meters per second times time. The time it takes from 0 to B, we said it 1 second, then is equal to 1 over 2 negative 9.8 meters per second squared. Then we multiply that by the change in time, which is 1 minus 0, so we have 1 squared, right? So now we can punch in our calculator to see what do we get for y. Sorry, my calculator is a bit troublesome, so let's try to punch this in. Let me open it again and see. Now we have 1 over 2 multiplied by negative 9.8. Now multiply this by 1 squared, even though that doesn't make any difference, but I like to write everything. So what do we get? Get negative 4.9. So get y is equal to negative 4.9. Now we can see no, this negative will only tell us no, this thing is falling in the negative y direction. So can say y is equal to 4.9, because this ball is going down, so this negative is showing us no, this ball is going down instead of going up, right? So now for us to get from A to the ground, because we were told to say calculate the height of point A above the ground, so A above the ground is equal to 2y. So if you multiply that 2, you had y, which is 4.9. Now 2 times 4.9, what do you get? You get 9.8 meters. It's very important to write the units, because you must say, now we must know that you are talking of distance, you are not talking of chickens, right? So that's it for 3.2. we got 3.2. Now that we found that the distance from A to the ground is 9.8, we need to write that no, this is 9.8 meters, because it might come in handy somewhere, somehow, we are not sure, but it's important to write because it might come in handy. So every time I get something, I decide to write it down. Well, now we jump into question 3.3. Question 3.3. When the ball strikes the ground, it is in contact with the ground for 0.2 seconds and then bounces vertical upwards, reaching a maximum height at point B. Wow, I like to draw this one. To show, to indicate what is happening, what is actually happening with the ball. This ball is coming down and then it falls. When it reaches the ground here, there's a certain time that elapses, which is 0.2 seconds, and then it bounces again to reach point B. Now we know that from the ground to point B is y. Remember, we calculated y, right? Y we found that to be 4.9 meters, which is actually the half of the total height of the building, right? So here we have got time that elapses, which is called 0.2 seconds. Now for this time elapse of 0.2 seconds, right, we call that thing, we call it an impulse, right? There is a change of momentum there. So you know that there is impulse there, but now let's go to the question and see what they want, right? So this ball here starts from rest and then travels the distance of y. That means finally we are at y minus initial, which is 0. So we can just write y is equal to vi t plus 1 over 2 a. Again with the time, we are starting from rest, which at t is equal to 0, and then we move to time t is equal to 1 second. So we can just write t squared, right? Now we substitute our values. What is the final? It's y. The one that we want, y is an unknown, we want y. So we can say initial velocity, we said it's 0 meters per second, because we said it starts at the rest, and then the time is 1 second. The time it takes to move from point A to point B is 1 second, right? Plus 1 over 2. The acceleration, we said it's negative 9.8 meters per second squared, right? And then the time is 1 second squared, right? Let's punch this in our calculator and see what we get, right? So we have this part here gives us 0, so we go 1 over 2 multiplied by negative 9.8, then times 1 squared. So 1 doesn't actually matter, so we get negative 4.9, right? So y is equal to negative 4.9, right? Now with this negative is telling you that no, this ball is going in the downwards direction, so you can just say y is equal to 4.9, because this negative is just telling you the direction that the ball is going down, right? So y is 4.9. Now we need to calculate the height of point A above the ground. So we are not done here, so we need point A above the ground. And how do we find that? We said if one point A above the ground, because this is half and that is half, so you have y and then multiply by 2. So to find point A above the ground, you need to multiply y by 2. So point A above the ground is equal to 2y, which is 2 times 4.9 meters. You must always remember to write the units, because it's very important to show that you are talking of distance here. You are not talking of chickens or cows or anything, so you must say we are talking of distance. So put the units. So 2 times 4.9, we get what? 9.8 meters above the ground. So it's very important now that we found this 9.8, we go and write it down to say this is 9.8 meters from A to the ground, so that if it comes in handy somewhere, somehow we can be able to extract it and use it again. Let me clean very nicely here. Now we can jump to the next question. The next question is question 3.3. So it says when the ball strikes the ground, it is in contact with the ground for 0.2 seconds and then bounces vertically upwards, reaching a maximum height at point B, right? So we have 3.3. Wow, I like to sketch this one to illustrate how is this ball going about this particular motion. So this ball is coming here to the ground, and then it falls here, and then a certain time elapses, which is 0.2 seconds, and then this ball jumps off the ground again, reaches the maximum height at point B. Remember, we know the distance from the ground to point B because it's y, because point B is halfway of the ground, which is half of the total distance. So here we get what? The height. It's 9.8. You divide that by 2, you get what? 4.9 meters. So point B is located 4.9 meters away from the ground, right? So here this time elapses, we have 0.2 seconds. Now when you have a ball, it strikes the ground, and then the time elapses, we call that an impulse. So impulse, we say F net is equal, F net delta T, which is impulse, is equal to M delta V. So impulse is equal to change in momentum. How do you get this? We get it from F net delta T, F net is equal to M A. We know A is equal to delta V over delta T. So you multiply by the T to get your impulse formula. So now we can go and check question 3.3, right? Well, so question 3.3 is saying calculate the magnitude of the velocity of the ball when it strikes the ground, right? So this ball is starting at a velocity of 0, and then as it goes down, the velocity increases to a certain velocity that we don't know and we want in this particular question, right? Remember, velocity is a vector, so it must have magnitude and direction. So, but in this case, they said they only want what? Magnitude, right? So they only want magnitude of the velocity. So don't bother yourself with calculating, with trying to say, no, my magnitude of the velocity is this velocity in this particular direction. No, they said they want the magnitude. So you must read the question carefully and give them what they want, right? So we can start 3.3. The first thing that we need to do, pick the best formula that works for us, right? So the first one says VF is equal to VI plus AT, but we don't have much information on A relative to the ground. As A moves to the ground, we don't have much information on the time A takes to reach the ground. So we can discard that particular formula and say, no, we discard this one. The second one says VF squared is equal to VI squared plus 2A delta Y, right? So we want VF, VI we know, the acceleration we know, and we have information on delta Y. So we can say, no, let's pick this particular formula. Let's take that one. No, this is the formula that we want. So now we go into answering our question. So we said we pick the formula, which is VF squared is equal to VI squared plus 2A delta Y. And guys, when I don't pick a formula, don't say, no, why aren't they picking this one, but I like this one? No, there are many ways to kill a cat, right? You can do simultaneous equation, do so many things, and then come up with the answer. But I always go for the straight one, the one which will give me the answer as quick as I can. So all the other formulas can also work, but for me, I decided to pick this one, right? So Vf squared equals to Vi squared plus 2a delta y, right? We want Vf, so Vf squared is equal to, we know Vi. Vi we said is 0 meters per second. Now we squared it plus 2. Acceleration we said is negative 9.8 meters per second squared. Now delta y, yeah, I want to talk about delta y, right? Delta y, this particular ball here has traveled a 0 distance, right? And then it travels distance of 9.8 meters in the negative y direction. So now someone can say, no, my initial for y here, my initial for y is 9.8, right? And say, no, my initial is 9.8, and then it decreases because the ball is up, right? So it decreases in height, and then it reaches the ground, and say the ground is my 0 point, right? If you consider the ground to be your 0 point, it's fine. You can do it that way. Use this one to be your initial. That's another way. Another way you can do this is to say, no, this is my 0 point. This is my 0 point. So my ball is going to travel a distance of 9.8 in the negative y, right? For us, I'll say no. Okay, let's say we say finally it's at a distance of negative 9.8 meters as your final, because delta y is final minus initial. So we say initially 0, right? We are starting at a distance of 0, and then we leave it, and then it travels distance of negative 9.8. But someone can say 0 minus 9.8. You will run to the same answer. So as I said, there are many ways to kill a cat. So now let's punch our calculator and see what do we get for that. 2 into negative 9.8 multiply that by negative 9.8. We get 192.08. 192.08 meters squared per second squared, because meters and meters will multiply each other, and then you get meters squared per second squared, right? Now in math you want to deal with this squared because we want Vf, not Vf squared. So we can take the square root of both sides. That's how we deal with that squared. So get Vf is equal to, what is the square root? What is the square root of 192? 192.08. What is the square root? To get 13.86. So because I round off to two decimal places, so I got 13.86. Now you take the square root of that, so you get meters per second, right? There you have it, your final velocity, right? I go again and then I say no, Vf is equal to 13.86 meters per second. But for you to answer a question here, they said they want the magnitude, so you don't talk of the direction. So it's 13.86 meters per second, right? So now, but when you consider the direction of this ball, right, your Vf should be negative, because this ball will be in the negative direction. So because now remember, when you take a square root, right, you have two answers which are plus or minus. When you take a square root, you have plus or minus the square root, right? So here you will have two answers which are negative 13.86 meters per second, and then the other one will be the positive. But here what they wanted, only the magnitude, so you don't entertain the direction. The magnitude is just 13.86, but when you consider a direction, because the ball is downward, so you say negative 13.86 meters per second. That's the velocity at which this ball hits the ground. Right, so now we can jump into our last question, right? Let's delete that, right? I don't want to delete this because remember I said no, this is very important, impulse, so I decided to write it here. It's information that I'm going to use here on this particular question, the information that I extracted from my statement. Now we do question 3.4. 3.4, calculate the magnitude of the average force exerted on the ball while it is in contact with the ground. So one F net. Here comes my impulse now. We are dealing with forces now, Newton's laws. So now remember, they are saying what? calculate F net. So if you have the impulse formula there, it says F net delta T is equal to M delta V, right? So you want F net, right? So, oh, this is delta V, sorry. So you want F net. So F net, you can divide by delta T both sides to get F net equal to M delta V over delta T, right? So guys, it's not a crime to substitute from here and then divide later. It's not a crime. You can do it any way you like, right? So I decided to first divide by delta T and then substitute. So M, we have M there. M is equal to 0.4 kilograms, right? Remember delta V is equal to VF minus VI, right? Now do we have VF? Well, we are not sure. Now we are talking of this particular impulse. That means we want VF here, because we are talking of this gap, this impulse, right? So we have VI here because the velocity at which this ball hits the ground will be your VI for this impulse. So we have VI there. VI is equal to negative 13.86 meters per second. We consider direction this time around. We don't only talk of the magnitude, but we are also talking of its direction, right? So we have VF. That VF is VI for this particular time elapse, so we can use that as VI, right? Now the initial velocity at which this ball will leave the ground, we'll need that as our VF for this impulse, right? So if we find the initial velocity for this at which this ball leaves the ground, then we have our VF for the impulse. So let's try to find the initial velocity, which will serve as our VF there. Let me scratch that out, right? Now we have some information that this ball jumps to a maximum height at point P. If point P is the maximum height, that means VF is equal to 0, because at maximum height the velocity is 0. So now we can try to pick a formula that will help us in calculation, right? We want VI, remember. So we have a formula, say VF, we want VF, right? Oh, we have VF, which is 0, which equal to VI. VI, we want VI plus AT, right? We don't have much information on how much time it takes to move from the ground to point B, right? We can discard this formula and say, no, we don't want this one. So VF squared is equal to VI squared plus 2A delta Y, right? VF, we have VF. VI, how about VI? 1 VI plus 2A. We have acceleration, and then we have information on delta Y. So it's a pick. Wow, this formula is very lucky today, so we are picking it. So VF squared is equal to VI squared plus 2A delta Y, right? So VF is 0 meters per second, right? We square that part, is equal to, what is our initial velocity? We want VI squared is equal plus 2, we have the acceleration, which is negative 9.8 meters per second squared, right? So you multiply this by Y. Sorry, I don't have much space. I'll multiply it here by Y. So this one is moving from the ground. It's moving from the ground and it travels a distance of 4.9 meters up. So it's positive. So finally is at 4.9. 4.9 minus initial is 0. So we have 0 is equal to VI squared. VI squared plus 2. How much do you get there? Let's try to punch our calculator and see what do we get. We have got 2 into negative 9.8. Then we multiply that by 4.9. So we get negative 96.04. So it's negative. So we need to change that to negative 96.04. So it's negative 96.0. Sorry, 04. Then we transpose these to find VI. So VI squared is equal to 96.04. We take the square root again because one VI don't want VI squared. It's my calculator. It's a very big problem. Must buy me a calculator, guys. So we get 96.04. What do we get? We get 9.8. So VI is equal to 9.8 meters per second. Remember, when we're taking a square root, we'll have plus or minus, but because this ball is going up, so it's going in the positive direction, so we just pick the positive 9.8. right? Now we can go into our calculation, because we have the initial at which this ball shoots away from the ground, which is the final for this particular impulse. So VF here is equal to 9.8 meters per second. Right now we can come and calculate 9.8 meters per second as final minus initial, which is negative of negative 13.86. Must be 86, right? So what do we get there? Over, sorry, that's a very big mess over there, but we divide this by our time. How much time does it take this impulse? So initially, when it hits the ground, the time is 0, and then it starts counting, and it goes up to 0.2. So finally it's 0.2 seconds minus 0.2 seconds minus initial, which is 0, right? So we can punch this in our calculator and see what we get. Let me first do that. So we can punch that in our calculator and see what we get, right? So we have 0.4 times 9.8 negative 13.86 over 0.2. If you subtract a 0, so that 0 doesn't matter. So we get 47.32. So we have 47.32. Remember the units. We are not talking of chickens, cows, or anything, but we don't know up until we write the units, right? So we have here kgs, and then if you subtract those, they give you meters per second, and then you divide by seconds, you get meters per second squared, right? 1 meter per second squared is equivalent to 1 Newton. As you can see from your formula Fnet, it says Fnet is equal to ma. Remember, mass is in kgs and acceleration is in meters per second squared, but if you calculate, this is force is measured in what? In Newton. So 1 Newton is equal to 1 kg meters per second squared. So this is equal to 47.32 newtons, because we are talking of force. Guys, thank you very much. That's it for this video. Come back for more. Come here. Let's solve with Chaba the scientist. Well, guys, I hope you're enjoying our content as we try to help you help yourself, because we can help you if you can help yourself. So it is very important that if you have any questions, you can put them in the comment section, and it's also important that you share with us the way you feel, so that we know how you feel about videos, and if we need to fix someone, we can go fix that particular thing, because we are humans, we all make mistakes. So here I'm standing in front of you to convey a very important message, guys. My message today says, please, guys, stay indoors, protect yourself from this coronavirus, wash your hands regularly. So it's very important to stay safe and study online.